Hello and welcome everyone. My name is Corey Lambertson with ASIGA. And today we're coming with you with one of our dental series webinars. We're going to be covering how to unlock the digital workflow beyond aligners. And today we have the pleasure of having our speaker, Dr. Brandon Owen from KL Owen Braces. Before we get started, I do want to give a little bit of a brief history about Dr. Owen, and then we'll actually jump right into the webinar. So Dr. Owen is an ABO certified orthodontist. He holds over 25 patents in the digital orthodontic space. He is an internationally renowned lecturer on digital orthodontics, TMD therapy, lingual orthodontics, and Dr. Owen has an impressive career history serving patients and the orthodontic profession. He is the founder and CEO of KL Owen Braces and the mastermind behind the Stride Digital System, which employs a kit of 27 patented braces with advanced AI software and true custom straight wire mechanics to precisely treat all three orders. Dr. Owen's impressive career and credentials include he is the winner of the American Association of Orthodontists Orthodontic Innovator Award. He is an adjunct professor at University of Alberta. He's a Sarver Institute faculty member, an Angle Society membership, Midwest component, consultant for more than a dozen digital orthodontic companies. He is an American Associate Orthodontist Foundation on the Vanguard member, and he is the first orthodontist in North America to do in-office digital indirect bonding and to do CAD/CAM 3D printed night guards, which is just impressive. So without further ado, I'm going to turn it over to you, Dr. Brandon Owen. Thank you so much for joining us today. We really appreciate taking time out of your busy schedule. And before I release you to our guests, just so everybody knows that this webinar is recorded and it will be released on our YouTube channel later. And so if you want to watch it again and take any notes, please do. And also, if you have any questions, please do not hesitate to ask. You can actually ask the questions down below. There's a chat box and a Q&A session. And at the end of the webinar, we're actually going to cover those topics and questions that you have.
Thanks so much, Corey. Thanks so much, everyone, for joining tonight. The goal for tonight is really to get beyond this discussion of aligners, because the orthodontic space pretty much has been ruled and dominated by that for decades now. But there's so many new and amazing applications every day. Every day there's new resins, new things happening. And this kind of seminar, I want to focus on two other key aspects of the orthodontic practice where we can really start leveraging 3D printing technology. And so it's going to be a short, sweet overview because this is a day-long topic. I could spend a full day on TMD. I could spend a full day on digital indirect bonding. These are the two focus points that we're going to have for tonight's discussion. But I really just wanted to kind of pack a whole bunch into a very short period of time just to point people in the right direction, because we have so many more resources if you ever want to pursue things further. But, the fun part of this is I've been a practicing orthodontist now for over 15 years. I had a staff of 16. I sold my practice in Colorado 2 years ago. We moved to Austin, Texas last year. I've got a new startup that's going. But I've gotten to do all these things, but first and foremost, I am an orthodontist. I'm in the trenches treating patients. That's what I love. That's what I know. I had a staff behind me that really helped me embrace these technologies. I think we are up to 16 digital indirect bonding systems that we've used over the last, decade or so. And you can't do that without a staff that's willing to support that endeavor, because change fatigue is a really hard thing. And so, but the cool thing that happened because of that is I really got to see the great points of all these different systems, but I also got to see kind of the Achilles heels of them. And really there were some big Achilles heels along the way of all these different digital platforms. And so when we started kind of constructing the KL Owen vision, it was, well, how can we create something that avoids and overcomes the Achilles heel, but keeps all the benefits of kind of the highlights of what these other systems that really were on their shoulders, kind of standing on the shoulders of giants, as John Pham would always say. I get to do a lot of things with different 3D printing companies. I don't just work for KL Owen. I try and help innovate in the 3D printing space a ton, in the imaging space a lot, in the software side a lot. So Anyway, this is one of my favorite things to do, is get in front of a group of dentists and orthodontists and just kind of talk about how can we move the profession forward in a meaningful way. And so, not to belabor this too much, and this is a very simplistic dummy down. There's so many other iterations of 3D printers now, but if you look at the core 3D printing technology in orthodontics, at least today, at least in the in-office setting, we're mainly looking at stereolithography. And these are things like the Stratasys printers and the form printers that use a laser that kind of touches the surface, and you're basically kind of polymerizing one point at a time. The Stratasys system would allow you to kind of print things in a support scaffolding. So there's benefits and cons to doing that, but the SLA technology still is dominating the space pretty well. DLP is kind of where more of the new stuff is all going. So it's digital light processing. Texas Instruments makes the DLP projectors, and they basically power all of these various 3D printers that we see. What I love about DLP is it's simple moving parts. There's one thing that moves up and down. There's a projector that's down below it. There's an aperture that opens and closes for a set amount of time. You can change the intensity. The Asiga printers actually allow so much more. When you're talking about material settings for an outside resin company, Asiga has more levers that you can pull to optimize material properties than I think anybody else. And that may be just what I knew 2 years ago, but when I was at the IDS in Cologne 2.5 years ago, I asked all the resin companies, tell me what's the gold standard for you guys when you're doing testing. And every single materials company that didn't make their own printer set, it was the Asiga. The UV Max was kind of the Cadillac. It was the gold standard. And we found that to be very much the case. If you want a precise part printed consistently every single time, the technology behind that UV Max is really, really consistent. And it's a tiny unit. It's smaller than almost any of the other 3D printers that are in the marketplace, but it's still a pretty sizable build plate considering its resolution. And so it's just a workhorse. And what's really nice about it is it's a totally open platform, meaning every single resin company will work with them and you can validate it. And this is a big deal because what I found is we're on our fourth, at KL Owen, we're on our 4th generation indirect bonding tray. Okay, so we started out with a Nextent resin on a Moonray printer, and then we switched to using a Dreva Photodent on the Asiga, and then we switched to a Keystone resin. Now we're using something different, but we're always kind of looking for new things to try. And if you have an ecosystem of printers where they're very closed, meaning they only have one option or 2 options available to you, and something better comes along, a new innovation in resin technology, a lot of times you're kind of screwed, is you're stuck dealing with their line of companies. And so one of the big benefits I found with the Asiga line is they really work with everybody. LCD printers are also kind of emerging more and more on the marketplace. There's a couple different ways these LED printers and LCD printers can work. Since the light source can either just be coming from the LED source directly, it can be totally a flat panel, but a lot of the LCD LED printers are actually using the LCD to block the projector light instead. So rather than actually having that be the light source, because there's some less consistent results sometimes with polymerization when you're using an LED source versus DLP, at least right now. They're using the LCD instead to actually make dark areas so the light just shines through in more fine detail in certain points. But this is an emerging space. And so LED, LCD is something that we're finding more and more, especially at the hobby level. It's getting better and better as well. But as I mentioned, the UV Max, you can get this in a couple different configurations. I definitely recommend the UV Max, not just the LCD one. You need that the light to get better polymerization, faster print time. This Pro 4K, to me, when I saw it at the IDS, was just incredible. It's if you have a bigger lab and you're trying to do a lot more throughput, this will print about 10, 11 arches flat in a really fast order. But beyond that, it's one of the highest resolution large platform printers in the world. And so you need to be printing a ton of indirect bonding trays or things that need that precision. There's very few printers that allow you to get high resolution on this big, massive. So if you're doing tons of throughput for a fraction of the price of some of the other big players out there, man, this is a beast. It's pretty phenomenal. And so if you're a bigger lab, if you need higher throughput, you need really high resolution. And again, you want that open platform. This 4K unit is just a really impressive unit as well. So again, going back to this whole, what are we using our 3D printer for? A lot of people come up to me and say, what 3D printer should I buy? And I'm like, I have no idea. What are you going to do with it? That's the first question you have to ask them, because, someone who's just like, I just want to see if I like it. Sometimes maybe it's just an off the shelf, couple $100 printer. They can see if they even want to mess with it, and they can throw it away when they realize, yeah, this is awesome. And then they want to scale up, then you probably are going to quickly upgrade. But when we start talking about things beyond just printing models for retainers or, models on a larger scale, we really have to start thinking about things like, what wavelength of light are we using? And so there's the conventional 3D printers early on, especially, were all 405 nanometer light source. A lot of the newer ones are moving more to a 385 nanometer. And the reason that that's so important is that these 385 nanometer printers polymerize clear resins, which are most of the newer emerging resins in the space, are clear, translucent. Without that pigment on the light source, it's very challenging for the projector to actually get that crisp resolution. But what the 385 nanometer projector does is it gives us, even with those clearer resins, a much crisper resolution. And so this was a test print that was done by Stephen Gardner from OrthoSelect, and he was comparing, it was the same printer. They swapped out the projector for the 385, and you can see what this test was doing is that they were printing different degrees of overhangs. And if you'll notice, the 3885 nanometer printer, that image is just perfectly sharp and flat. The more of an overhang, the more of an angle of a part that you're printing with that 405 nanometer, the more of a wavy edge that you have. And with a model, it probably doesn't matter as much because we're just making a liner off of it, and a little bit of inaccuracy doesn't matter too much. When we're talking about things like indirect bonding trays, though, and direct printed aligners, those overhangs really do matter. And so as we think about some of the new materials that are on the horizon, all of us have seen, this is a material that I saw 2.5 years ago. There's a ton of new ones that are direct printed aligners that are, potentially still slow to come. I don't think it's right around the corner, but they're definitely on the horizon. And so you want to be thinking about these things if you're going to put a big investment in 3D printing, you probably want a machine that's going to be able to manage this. But obviously direct printed aligners, there's so many cool things that we can do with it. There's less waste, obviously, hopefully faster time. We don't have to cut everything out. But the other cool thing is with a thermoform retainer aligner, we have to have uniform thickness. But if we're 3D printing a part, I can make it thicker in certain areas to make it more rigid in certain parts of it. Think about anchorage generating, and we can make it thinner in other areas where we need more flexibility. We can also do indents into the teeth rather than having them always be an attachment that we have coming out of the teeth. So we can create some really cool pinpoint force application. So the biomechanic properties that and opportunities that come along with the direct printed aligner, to me, is just super fun to think about. Because there's so much additional biomechanics delivery options and opportunities that come with it. So it's a little bit, still, this was 2.5 years ago. It was too rigid in the front, really, really flexible, and kind of too squishy in the back. Polishing and post-processing these things is still going to be a challenge, but they are making leaps and bounds. And you guys maybe even have seen the thermoelastic, where it goes into a warm dish of water, and it's kind of all distorted in like a Nai-Tai at warmer temperatures. It goes back to its original shape. So some really cool resins that are coming out of kind of Korea, Japan, some of those other areas back in Asia. So indirect bonding is another application. It's the one that I really am rooted in the most. We're printing these things all day, every day. And it's really important for us when you think about how we need to have this bracket in order to fit into that bracket box. It has to fit very intimately. Otherwise, it's either going to fall out or get pushed out. So we have to have really tight resolution. In our first rounds of 3D printed indirect bonding trays, because the resolution just wasn't there, you can kind of see how cloudy it was. And all we could really do with this is we had these vertical walls, and it was a friction fit. So the bracket would slide in, and it was a vertical kind of channel. And then as we loaded the adhesive, the bracket could actually pivot. So with custom braces, especially if the bracket's actually pivoting a little bit as you're loading the glue, you may end up changing the prescription from what you intended it to be because of that pivot. So with these newer resolution printers and also these newer, better resins that were coming out, now we can actually leave the bracket slot in, and we can leave some channels, and we have some retention grooves in our brackets that now when I put a bracket into the indirect bonding tray, it actually snaps in. So there's no more of that friction fit. We know it's there. And as we're loading the glue, it's going to be held in that position. So higher resolution really was critical, as was the better resin development, in order to make sure that we're really getting these things seated exactly where we want them to be as we go to the bonding. And so as I was kind of going through this whole exploratory thing, it was really about, hey, can we achieve true straight wire? And that's where I went out and did every digital IDB thing I could find. I did tons of lingual systems, tons of labial systems. Some were custom, some were non-custom, things with the wire bending mechanics, all these other things, right? I tried everything. And what I found, thinking that this statement was absolutely true, was that it's not even close. If you put the braces in the right place, the only thing you get precise with any sort of precision whatsoever is the second order. That's it. The up and the down. And the reason for that is, if you think about the first order, the ins and outs, if we have a one size fits all prescription, how many times are the teeth, every single tooth, exactly the right height in order to make that bracket prescription line up the central groove and lingual cusps perfectly? Almost never, right? And so when I was doing Sure Smile Fusion, we do digitally guided bonding, we'd order the custom wires, and I'd see all of these in and out bends. And I'm like, what the heck? I measured these things down to the 100th of a millimeter. I shouldn't have to see any of these bends in the wire, right? But again, it's not the right shape on every tooth. And so even with the Fusion, we were still seeing lots of in and out bends. And even worse than that was the third order bends. I mean, we had 30, 40, 50 degrees sometimes bent between two adjacent teeth because we weren't getting a couple. We were not engaging the bracket slot in a way that was actually moving the third order where it belonged. So the interesting thing though is you could actually set these wires flat on the table, right? Is I could get with digital IDB, I could get these things. The second order was perfectly flat. I could dial that in just great because, you know, we have that 1925 wire for finishing the 22 slot. There's only like 2 degrees play in that scenario. And so when you put that big wire in, the roots and the height are going to actually end up being where they need to be, at least in the second order. It's the first and the third order. So perfect bracket positioning gets you a failing grade. You get a 33% on the test. That's it. And so I actually found that digital indirect bonding didn't offer very much more efficiency. If anything, it probably cost more than my analog indirect bonding. And maybe it reduced our debond rate a little bit, but jumping from indirect bonding to digital indirect bonding, I didn't see that much of a gain, quite honestly. And so, and again, this is the torque play, right? In a 1925 finishing wire, in a 22 slot, these are GAC brackets, high quality, well made. But look at how much play we have. And what you think about when we see that 45 degrees of play, so it's 22.5 per tooth. And when you have two adjacent teeth, that's a total of 45 degrees of slot play between two teeth. And if you watch this second molar, watch these lingual cusps, watch the marginal ridge. So right now, I'd say this is a pretty optimal position. We've got kind of the curve of Wilson level within. But this lingual cusp can actually travel over a centimeter on an arc for this second molar. So look at how the third order affects the second order. It's massive, right? And so how many times that I've done detailing bends and I look at the bracket positioning, the height was perfect. I got the bracket where it belonged, but because we didn't get that third order, because the wire didn't deliver that proper torque, we still ended up with all these height discrepancies. And if you look in the back, it tends to be more second order discrepancies. If you look in the front, the torque slop tends to play more into first order discrepancies. And this is only 30 degrees of torque slop. This is 15 degrees. So this would be analogous to a 2125 wire. And look at this occlusion. It's a train wreck. And so what I can tell you is digital IDB is awesome. It's going to save you time and it's going to help you hopefully with repos and not creating iatrogenic rip tip where you now have a tooth that you have to recover from that's 15 degrees off. But beyond that, you're not going to necessarily get this true straight wire approach. You're still going to have to make manipulations in the wire, first and second order. The second order, we always make second order bends to actually compensate for what's really a third order issue. And so what I love about going custom and slot filling mechanics is that we can actually get to the true straight wire. We can control things in all three orders of movement. And so the way that we tackle this with KL Owen, and there's other great digital custom systems out there too, just to give you a little bit of an overview of what we do though, is we have this kind of pre-assembled, prefabricated set of brackets, and they are basically iterative changes. So every 10 degrees, we have a new shape bracket. So we have a plus 15 degree torque and a plus 5 and a minus 5 and a minus 15 and a minus 25. So if your lower right second premolar needs a negative 12 prescription, the software is going to pick this 15 degree torque bracket. And because of that, as I showed you, that little slot tolerance, when we snap this into the IDB tray, it's going to build in the last little bit of torque into the bonding base when you glue the bracket to the tooth, just like an attachment template. And it's less than 1/10 of a millimeter. It's actually 0.08 millimeters of adhesive. That's the maximum that you would need to build in that last little bit. So you're not going to get more debonds because it's such a small layer of the adhesive. It's actually better than what you would typically get after seating the bracket, moving the bracket, and maybe not seating it all the way again. This is actually going to get you closer to the tooth surface than what we're typically seeing. And then we also have a high profile, a medium profile, and a low profile bracket, so we can get the perfect in and out position. So if the central groove needs to be kicked a little bit lingual, we can use a higher profile bracket so it lines up with the appropriate position. And then every patient gets their own custom prescription. And I can't tell you, it's almost always that we see that the right side of the patient's mouth and the left side of the patient's mouth aren't the same. Meaning, even within the same patient, if you think about a one-size-fits-all prescription for all of the patients we see, it seems crazy, right? And not only that, but even if you have the patient sitting in the chair, we're off by over 10 degrees or at least over 2/10 of a millimeter from right to left almost every single time, even within the same individual. And so that's pretty a staggering figure. And so that's what I love about every patient gets exactly what they need to get the tooth the optimal position. And then we fill the slot. So we have a 19.5 slot bracket. We put a 1925 nickel titanium wire that we manufacture as well. So we know what the tolerances are there. So when you put in that finishing wire, you actually get all of the lingual cusps where they need to be, all the central grooves lined up. So it really takes away the bending from the whole process. And you can print this in your office if you want to, or you can have our lab do everything and send it shipped to you. And it's 2 weeks turnaround from our lab. It's 1 week typically if you have the 3D printer in your own office. So that's the cool thing is you just inventory it and then you just stamp the red bracket in, the yellow bracket, everything's easy and color coded. But this is the workflow. It's the aligner workflow where we start with the scan. Once we get the digital scan, we segment the teeth. We put them in an optimal position. The orthodontist can come in, make minor modifications, change anything you want to change. And then this is what the software is going to do is it's going to pick for every tooth, the right thickness and the right angle for each bracket. We do the 3D printing, pieces come out, they're ready to load. And basically it's just then indirect bonding. And these newer resins are so much better than the earlier resins. Again, both with accuracy and just ease of removal. And so what I'm just loving about this is it's the barrier to entry in 3D printing is easier and easier and easier. But what I can tell you is that indirect bonding is so much harder and you have to be so much more meticulous with how you're handling the resins and the parts than you are with just model printing. We're typically talking about 60 to 70 microns minimum for XY, usually 50 micron height in terms of the build layer versus models you can get by with 100 pretty easy. And so we really just want to make sure that we're cleaning out all these parts. Because if you have a little bit of uncured resin going into the cure box when you're making an aligner on a model, there might just be a tiny little extra gap between the suck down and the tooth when you actually go to insert it. Because we're dealing with an intaglio surface that's actually going to go either to hold a bracket. If there's any extra resin in there, it's not going to fit and it's going to fall out, or it's going to rip the tray, or it's going to just not seat all the way and it's not going to be where you want it to be. Or even worse probably is if you have resin in like the cusp tips of the indirect bonding tray and you don't get it cleaned out, when you go to seat the tray, all of the brackets are going to be too far occlusal. And so it's really, really important that we go through a much more rigorous washing cycle. And so we typically would go through kind of 3 wash cycles with magnetic stirring plates or oscillators or, ultrasonics, whatever you want, using IPA that's at least 92%. We typically are using 99% IPA. So after we kind of take it through the various processing, we need to think about just keeping all this air. We want to rinse off all the IPA. And this is what's really important is we watch as that evaporation of the IPA is happening. I want to make sure that there's no material flowing across the surface, because IPA is just going to evaporate kind of on 99%, especially. It's just going to kind of evaporate. But if you see kind of a sledgy layer flowing on the surface, that's resin. You've got to go back in with the toothbrush and you've got to clean that out. It's probably time for you to change and cycle out your alcohol, at least put in a new clean wash at the end of that process. Because if you don't do that and then you put it in the light curing unit, you're kind of in trouble. Another thing that most people don't think about or even maybe know about is some of these materials have an oxygen inhibition. Well, most of the materials have an oxygen inhibition layer, but sometimes it really matters depending on the resin. And so a lot of times the oxygen inhibition layer leaves a tacky surface to the printed part. And these are 3D polymer. We're photopolymer curing a resin on our 3D printer. And as we glue the braces on, we have a primer and a composite that's a photopolymer as well. And so they stick to each other like crazy. And so if you have that tacky, sticky layer already, then you're going to potentially have a really tough time removing the indirect bonding tray. Some materials are a lot easier to remove. The oxygen inhibition layer isn't an issue. You don't need to worry about this. But if you have a surface that's very surface-free energy of one of these materials that's really reactive, a lot of times what can help is to, like Dreva and some others, like Otaflash, they actually have a nitrogen tank that you can hook up to the unit. So it actually flows nitrogen in before you hit the flash button. So you're actually devoiding the whole area of oxygen as it's flash curing. They tend to be pretty expensive, usually $4,000+. A dental hack that you can do is you can get a nitrogen tank for about $300 at Home Depot or some other places, gets with a regulator. And we take a Ziploc bag and you can just blast that little air into the Ziploc bag with the printed parts and put it in that way. Another solution, which works maybe even a little bit better, but is a little bit messier and takes a little bit longer, is if you take just a Tupperware glass bowl, you put some water in it with a tiny bit of dish soap, because we don't want bubbles forming on the part. And the dish soap kind of acts to keep those bubbles from forming on the printed part. So you can actually submerge it in water. It's another way to kind of avoid that tacky stickiness of those. So make sure that as you're looking at how to post-process these, are you needing to worry about the oxygen inhibition layer or not? And those are just a couple solutions that you can do if you don't want to have a really expensive unit. So, and then finally, it's make sure with FDA cleared pieces, these things are going in the mouth. Models, you can use resin from wherever and, not follow standard protocols in terms of light curing. Things that go inside the mouth from a 3D printer, they need to be cured to the letter, right? As you want to follow the FDA's regulated protocols, you need to make sure you're using the white wash cycle. You need to make sure you're using like flashing unit. You need to make sure if they need heat that you're getting it to the right heat. And some of these cheap curing boxes aren't going to get you where you need to be, especially when we start talking about night guards and other things. And so just make sure that you're following for intraoral things that you're printing. They're actually going straight from the printer into the mouth. Look into the material data sheets and just make sure you're following proper protocols. So kind of transitioning out of the indirect bonding space into the 3D printed night guards, Tmj Splints Orthotics. A lot of these patients come into our office, and orthodontics especially is just kind of, I think, done I don't know what to do. Like a lot of people with orthodontics, Tmj is kind of a 4-letter word, or it's this mythical thing that nobody ever really said. It's all hocus pocus anyway, so why should I really dive in? And quite honestly, it's rightfully that way, because we've had all of these gurus and really powerful leading figures through the occlusion years that the reality is they agreed 90+% on how to manage and treat these patients. But the kind of the ego behind it was that you guys are totally wrong, even though it was a subtle difference. And so because we saw from the external, all these groups fighting with one another saying, you're terrible, you're terrible. Well, the reality is most of them were doing great things. Most of them had amazing success rates. And so I actually went to learn from all of them. I went to, you name it, and I've been there, LVI, Pankey, Dawson, Coy, Spear, Okeson, Tanaka, Green. These guys are all my mentors. Droder, just amazing people. And they're all doing things the right way. And certainly, learning from kind of this myriad of places, you kind of just come back and say, well, what are the core things that we need to be hitting every time? And one of the interesting things is I look at the patient like this, and this is probably the most similar presentation that I see in my TMD practice. the occlusion looks pretty good. When I do CR manipulation, there's not a significant shift. But as I look at tomograms, or if I look at now my CBCT, if I see that condylar head is closer to the ear canal, the external auditory meatus, than it is to the anterior eminence, we've got a problem. So here is this is a 2D image on a pansep. It was my early unit that would allow us to take a bite with the teeth barely apart, where the condyles were in kind of their neutral position. So essentially a pre-centric occlusion, barely out of centric occlusion. And then there's a second scan where the patient bites together all the way. So this shows us where the condyle wants to be in its neutral natural state. And then as you see this patient hitting together, then you see how it's shifted backward. And then so you can see the retrodiscal space here versus biting together, retrodiscal space versus biting together. So what's happening here is she bites down, she's hitting heavy on the front teeth, and as she squeezes together, the condyles are getting forced distally. And another way you can really check for this is just to put your finger on their front teeth, have them tap straight up and down a whole bunch of times, and you're going to feel anterior fremitious in these patients. So if you see a condyle position where the jaw is further back than it is, there should be more space behind, not in front of the condyle. Usually you can just quickly test for fremitious and say, yep, you got heavy contact. Another really great trick that you can do is, in a lot of these patients, like deprogramming and centric relation is really tough to find, because as they start getting closer to MIP, the posterior temporalis fibers start firing and actually pull the bite back to avoid the collision of the centrals. So what you think is centric relation really isn't. It's an adapted centric being assisted by the posterior temporalis fibers. But if you have somebody kind of open up and goes 10 times side to side each direction, what we're doing is we're rehydrating the disc, because it probably has been compressed and squeezed out the fluid. So it's a compressed disc. And then we're also kind of just stretching out and resetting the lateral pterygoid muscles. And then you just have them gently tap together. Tell me where you feel you touch first. And usually they're like, it's here, or it's here, or it's like both sides here. And you're like, yep. So it's just a great way for them to kind of self-realize that, hey, listen, what's going on in your mouth is that your teeth fit together great in one position, but your jaws are out of position when your teeth are together. And when your jaw's in a good position, you're only touching on a couple teeth in the front. So you have two kind of positions, a good position for your jaw and a good position for your joint. And what I see the most when we think about people with TMJ is that usually they're having this constricted envelope of function and they're clenching and grinding a lot. And so we actually, as Corey mentioned, made the first 3D printed night guard. And, it took a long time to go into 3Shape at the time. We designed everything. This is a modified Tanner appliance. It's kind of the new Panky design, where everything is perfectly flat in the posterior. We have a slight anterior bite ramp. But it's really cool to be able to dial in this kind of lingualized occlusion digitally. It just took a lot of time, especially back then. It's gotten so much better now. And then we took it to the 3D printing. One of the most important things with this was the print scaffolding, because obviously we want that occlusal surface to be perfect, because we built the splint to be perfect. So if you have all of these supports that are too big, it really affects how obviously the teeth are going to hit against the plastic. And so Chris Cabot, one of my close friends, this was our first kind of project we got to work on together, is really building these really fine scaffolding points that supported the splint. So when we wanted, coming off the 3D printer, we would easily be able to kind of tear these pieces off just with their thumbnail and not have to do much at all. So you can see this is just thumbnail removal, and those little support scaffoldings are, pretty much we're at true bite. So I did about 3 of these 3D printed splints, and I stopped right away. So number one is the designs it was just too tight on the teeth. So I spent way more time having to do internal adjustments to relieve the lower incisors, upper incisors, depending on which we were doing, as the upper or lower splint, on the buccal surfaces and the embrasures, just to make it so it wasn't fitting too hard. Then we're also having some issues with shrinkage. And so even if we got it fitting, a month later, it was still shrinking. It's turned yellow. And with that shrinkage, as they put it on and off and on and off, they just started fracturing left and right. And so as much as I was like, yes, this is awesome, sometimes technology, the bleeding edge stuff, you realize you have to know when to pull the cord, right? As it was not ready to use back then. And so The awesome thing though was at the IDS meeting, probably one of the things that blew me away the most was this Keystone Key Splint Soft. Having done, I think I've treated over 1,000 TMJ patients. They drop that splint even 2 feet onto a tile floor, it shatters. This thing, you could throw it across the room against the wall. You could drop it off the roof. We've driven over them with cars. You can squeeze them like crazy and they just don't break. And so it really was amazing because we could actually now start printing things that were smaller. We didn't need this massive bulk of plastic. And so the other cool thing about this material was that as it warms up at mouth temperature a little bit. So when you put it in, where most splints would be like, oh, it's way too tight up here, just after 30 seconds, it softens enough to where it's not typically putting on that orthodontic force. So patients, we didn't have to do nearly as much internal adjustment of this because the material of the resin itself would allow it to be much more comfortable. We didn't have the shrinkage issue anymore. We didn't have the yellowing issue. If anything, we had this light blue color that as it fades, it gets a little bit clearer. So I really liked having that little bit of blue pigment. It also is great because as you're printing on a 405 nanometer projector, if you're using a different type of printer, that polymerization is more consistent on a 385 or a 405. So here's just some of the stuff we were doing, throwing it down, 20 foot off steps and not having it break, squeezing it like crazy. Try this with any other splint material, good luck, right? It's just, you're gonna get things breaking like crazy. And then this is just showing with the hair dryer how much it really softens. You can see how pliable it becomes. So really cool technology. And like I said, resins just keep getting better and better and better. And so a patient comes into me, I think, one of the things that I think is maybe even more important than knowing what to do when you're looking at seeing a new TMJ patient coming in through the front door is being able to communicate with them in a way so they can actually understand what's happening to them. I can't tell you how many 6th and 7th opinions I've seen, even in the last couple of weeks. I've seen 6th, 7th opinions, and they always think they're going to know everything already. They've already heard everything. And they always walk out saying, wow, I actually finally understand what's happening, what's causing this. And so really, I think maybe the most important part of today, or at least of TMD thinking, is you really need to think about putting this in patient terminology that they can really walk away with and understand. Because what we found is, and I showed you on those videos, is it usually takes 2 things for people to have terrible TMD dysfunction. Number one is you got to have a bite that's causing a dislocation of the joint typically. But you could have the worst bite in the world, and if you're never clenching or grinding, your joint tissues aren't being overloaded, your muscle tissues are relaxed, you're going to be feeling great. So just because you have a shift or just because you have, a bite that's not perfect, for most of us that doesn't matter. But if you're clenching all the time, then you're basically, not only are you overloading the muscles, but you're also overloading the joint tissues. And so the analogy I like to use is a weightlifting analogy. Is imagine you were to go to the gym and pick up a 10-pound dumbbell and start doing this over and over for 8 hours straight. By the end of the day, in the morning, you're going to be feeling like, oh, that's kind of sore. But with most of these patients, because they're only touching on certain teeth early, and then we've got certain single bands of muscle fibers trying to avoid those collision points as they close together, it's like picking up that 10-pound dumbbell with 2 fingers. Right? Is all of the weight is not being supported by all the muscles equally. We have certain muscles that are doing the lion's share of the work. And if you do a TMJ exam, you'll feel these tight muscle points that it's either myalgia or myofascial pain. And you can kind of feel those knots and they're like, yeah, that's a sore spot. It's a 6 out of 10 on the pain scale. So it's because they're only using certain muscle fibers, not all of them. And on top of that, because their jaw's out of position, it's like they're doing it hunched over sideways. And so if you go to the gym to a personal trainer, they're going to tell you use perfect form. Why? Because we don't want you to damage your joints. We don't want you to pull other muscles because we are lifting a lot of weight. We want to make sure that we're only focusing on those certain muscle fibers that we're trying to localize. But when we have these TMJ patients, you can think about how, okay, if we're hunched over this way, my elbow and my shoulder are having to compensate. So we end up seeing other muscles back in the neck and other places that start having to support that. So what I tell people is I can't stop you from clenching unless we do Botox, which I could start with Botox, but you're going to spend thousands of dollars for me to really get all the muscles dialed down. Or we could do Flexeril, muscle relaxant to kind of calm that down, but you're going to have to do it forever. It's this repeatable, vicious cycle. Or I can give you perfect posture. I can design some plastic that's going to allow your jaw and your muscles to work together. So even if you're clenching, at least we're keeping everything where it belongs, and we're using all 10 fingers to support that, and we're using perfect posture as we do so. And so, man, I've used all of these. I've used them all. Some of them are, sleep apnea appliances, and there's TMD implications with those things as well. Flat plane, Coista programmers, Droder splints, Tanner appliances, B splints. I mean, just all sorts of different things in here. And I've used every single one of these things. And it's really been interesting for me to kind of dial this back. And, the big thing that I want to kind of talk about is these partial coverage splints, because they are so easy to use and they're so quick to insert. You can go to a weekend course and learn how to do like an NTI or a Gelb appliance, or, it's one of these posterior coverage or anterior coverage splints. And the reality is 19 times out of 20, they're fine. 29 times out of 30, they're fine. But when things go bad with these NTIs, especially the anterior programmer ones, they go really bad. And so this is showing you a case that I saw. It was simply a dentoalveolar movement. They had actual just relative incisor intrusion, right? And the reason we know this is because the premolars are still touching. When this person puts in an NTI, the places where the teeth aren't touching are exactly where the plastic is. So we've had dental compensation that's adjusted for that. And so this is, okay, the teeth moved is the biggest thing, right? So that's a scenario, and we see it a lot. I know most people say that, no, I never get that. I use these things all the time. It's because they come to a specialist and they don't go back to that dentist again. And again, another thing I will tell you if you're trying to treat TMD is I always say, this is not a board violation. This is not outside the standard of care. There's dentists all over the place using this. And most of the time they work great. So this is not trying to say I'm better than the last guy. It's really about, hey, I just want to help you. And no, this is very common. This is something that we see, routinely. There's a great way to manage this. And I've never had to be a defendant against a previous doctor for doing anything bad, because we say that, no, this is within the standard of care for sure. But there is a better way. There is a better way. And this is the worst case scenario. These things are when things are not so great. And so unlike the previous picture that I just showed you, here we have a totally divergent occlusal plane. So before it was like this, the teeth shifted, so that where this plastic was, now these teeth are just touching in the back molars. That's it. So one of four things typically has happened in this scenario. Either they had a centric relation MIP where they were doing a pivot around, and you just deprogrammed it, and this is their true CR. But if you did that because it was a grinding issue, and now they can't bite anything and eat anything, they're pretty ticked off. But even worse than that is when you do these NTIs, you're transmitting in someone who's a clencher or has some sort of parafunction, all of the force into the disc directly. If you think about the bite, we have molars that stop the condyles from seating past the molars. It's the stop to make sure that the disc is protected. When you take away that posterior stop, even if you're decreasing how strong the muscles are pulling, they're still putting a lot of pressure and loading all of it right into the disc. So what if the Piper classification is like a 3A and they're kind of clicking on and off, but because of this, all that pressure, you've actually slipped them off to now a 3B, and now they don't reduce anymore. Or what if they go from a 3B to a 4A, and ouch, you just created something where they're in a world of hurt, now they're on the retrodiscal tissue. So that's not a great scenario, and you can't undo that. Once you've advanced that disc disease, it only keeps getting worse. It could be that you've actually perforated through the disc altogether. So maybe instead of the disc slipping out of place, that pressure can over time, and this is Tanaka's cadaver studies that he was seeing coming from these NTI patients where the condyles are actually going through the disc. And that's when I stopped using NTIs. Or it's just condyle remodeling. Is there an injury to the joint itself? And now the condyle is getting shorter, and now you've got this adapted open bite. But the reality is these three bad things were caused by the appliance we used. And my first rule in TMD therapy is I want to leave things healthier, not less healthy. That's my number one. I don't want to violate that. Right? It's non-malevolence leads the pack, especially when we're treating someone that's really suffering through this terrible disease condition. And so here's the opposite end, which is, hey, this is an easy weekend course as well. Mora, Gelb, Green. There's a whole bunch of different variations of this. But I would prefer people use this instead, because usually the worst case scenario is just that dental super eruption in the anterior teeth. You still are protecting the condyles, and it's still, you only have to balance usually 6 or 8 points of contact, and then the excursives are really easy to do. So anyway, here's another posterior coverage splint, really easy to use, really quick to insert. But this is what I still had to stick back to. I tried all these things and I was like, you know what? I just was finding that it was worth spending the hour to balance a perfectly inserted centric relation split. Maxillary, mandibular, I used them all. I preferred mandibular, but I know people love the maxillary. If someone walked in the door with a maxillary, I would realign it and use what they already had. So, we needed these 18 points of contact at exactly the right time. And then we have to build in the left excursive, right excursive, where the canines are separating everything else instantly, but shallow guidance because we don't want to trap them in. And then as they come back into crossover, you need to make sure that they're not picking up the lower canine and causing periodontal trauma. And then we had to worry about incisor intrusion. And so even if you know what you're doing, this takes an hour. Sometimes it's 45 minutes if you're lucky. Sometimes it's 90 minutes, but it takes for freaking ever to put these in. And the problem is, because there's inflammation, is I balance this perfectly. And guess what? These muscles are inflamed, the joints are inflamed. And as they start calming down, the bite's changing position. And so I have to have you back in 2 to 4 weeks to rebalance it all over again. And we have to keep doing that every month, trying to chase that kind of neutral position. And when you come back 2 visits in a row where I say, oh, good, I don't have to adjust anything anymore. How do you feel? Usually they say, I feel great. Well, that's taken me 3-4 hours of my labor. I can't delegate this to an assistant to really do that well. And so this is different than a night guard where there's not inflammation. You can put it in, you can kind of get it close and you let them go. When we're talking about TMD, it needs to be precise. So you've got to have the biggest mistake people make when they're treating TMJ issues is not seeing the patient back. So going back to that weightlifting analogy is I put in this, they've got this condition where these 2 fingers hunched off this direction. I put in a night guard, I give them perfect posture. The inflammation calms down. Now they're starting to lean off this way using these 3 fingers instead. And guess what? If you don't go back in and readjust that and give them the perfect posture again, they go into a new long-term inflammation loop again. And so the number of splints that I see come into the door when they say, yeah, I've been wearing this splint, but it's not making me feel very good. And I do the centric relation bite without the splint in, and they've got a 0.5 millimeter shift to the left or a distal. And then I put the splint in and they got a 3 millimeter shift to the right. They're like, oh crap. Yeah, this is dislocating your jaw position worse than what your natural teeth are doing. Stop wearing this thing until we can get you back in and get you refitted for something better. So rebalance, rebalance, rebalance. That's if you want to be successful, even if you're not talented in terms of how you adjust the acrylic, just repeating the process and getting it rebalanced, rebalanced, rebalanced. A lot of times you're going to be successful just because you're calming down the inflammation. You're finding what their true because everything is an adapted centric occlusion. We want to find out what their true centric occlusion, which is pain-free, neutral position, a repeatable bite, 2 consecutive visits. So, you think about these things. I thought about these things a lot over the last 3 or 4 years. Full coverage splints are awesome. They protect the teeth, they protect the joints, but they just take so much doctor time. I charge $3,000 for usually a 4-month continuum of treatment. And then we charge $200 per visit. After that, you need to charge for the treatment because otherwise they're not going to show back up. And so you can't just say, hey, we can just put this night guard in. It's $2,000. We'll see you later. No, you have to make sure they're coming back in. So it's a treatment regimen. Charge whatever you want to charge, but they needed the rebalancing. It's technique sensitive. You got to get these 18 points. You need to know about crossover movement. You need to know about functional envelope violation. Partial coverage splints, you can go to a weekend course, put them in quickly. They're super easy to use. You can feel like a rock star right out of the gate, but they can change the bite. They typically can need orthodontics to follow up treatment, or hopefully you haven't advanced the joint condition even worse. And so, as I said, do no harm is number 1 for me. No contact on inclines is the other big one. Is when you have an incline pushing the jaw joint some direction, the body doesn't like it. That's why these deprogrammers have become so popular, is because it kind of lets you get to that inflammation-free position more directly than having to do this. And then they're hitting over here and adjust that, and then hitting over here and adjusting that. Stable joint position, meaning it's repeatable time after time and with no inflammation active, and shallow guidance. And then the hopeful one is quick insertion. And so can we find a solution? This is what I was pondering about 3 or 4 years ago that protects the teeth in the joint with fast insertion. And are there full coverage options that are less technique sensitive? And this is what I created. This is kind of my tripod design. So with these 3D printed resins now, because they're so much thinner, we can actually make an upper and a lower piece that actually have the same distance between the incisal edges as the conventional way of doing it, which is amazing. And so this is kind of the design we use. We cover the non-functional cusps of the second molars to prevent super eruption. But basically all I have to do is I've got a flat piece on the top that's perfectly level. And then we have 3 elevations on the lower that are touching that flat surface. And all I'm adjusting is these 3 points. So instead of having to get 18 points of contact simultaneously, all I'm doing is making sure they can hold articulating paper in these 3 points. And we make sure from side to side that there's smooth movement, like a glass or a ice skating rink where there's no bumps or friction anywhere, and we're done. And so typically inserting one of these splints doesn't take me an hour, it takes 5 minutes. And doing a rebalancing doesn't take 45 minutes, it takes just a matter of 5 to 10 minutes. And in an orthodontic practice, I had to break out my TMD days and be separate days altogether because I couldn't manage seeing adjustments over here and focusing on TMD over here. We tried it for years and I was running behind. It just pretty much the patients that we'd see would always throw us way off. And so to be able to have a solution where I can put that person into an exam check, or an obs check or a retainer check spot and be fine, it's really allowed me to shrink the cost of delivery of TMD. It's gotten us a lot faster to the end, getting people comfortable, and it's way less technique sensitive and way less stressful on me and on the team. So, and the other cool thing is whether it's disc, capsulitis, whether it's myalgia or myofascial pain, I start with the same appliance. If you go Spear, they have, if it's a myalgia, myofascial pain with no load testing, you can use this. If it's this scenario, you can use this appliance. And it's this whole grid that you have to look up, okay, what's the scenario? And I'm going to pick this one. The cool thing is you don't have to worry about that. This is the starting point for every patient. I can do anterior repositioning with the lower piece if I need to. If we still have capsulitis after 2 or 3 months, I can adapt this one, bring the jaw forward, see if decompressing the retrodiscal tissues helps. If we still have muscular inflammation, I'm going to Botox. But instead of giving 3,000 or 4,000 units, I'm probably only needing 50 to 100 units to get just the small muscle fibers that are still residual. So that's the fun thing. And getting a chiropractor, physical therapist, massage therapist, if there's neck injuries involved as well. Sometimes these things translate from the neck up around to the jaw. Other times it's the jaw kind of going back to the neck. So even at your exam, you want to figure out where's the pain worse. Is it here or here? Some patients, I don't even start Tmj splint therapy because the neck pain is so much more severe that it might just be a residual from, if they get this fixed, this goes away. But more often than not, when they're coming in, it's TMD stuff. So I'll kind of leave you with this quick little video showing you the 1 minute balancing. This came right out of the box from the lab. I'm just tapping together. I'll do centric relation, check all 3 points of contact. I'm pulling laterally on the paper to make sure I can hold this 60 micron Accufilm. Take it out. I'm just going to balance the one spot that's high. And I've lost like 30 pounds since this video was taken, so it kind of cringeworthy to see this thing popping up again. But a lot less gray though, right? I feel like running a company is grade my hair very, very in an accelerated way. But so once you get those 3 points of contact, it's just side to side and make sure there's no hangups and you're done. And so, the beauty of this to me is it's accessible to all orthodontists, it's to dentists. I think it's predictable. You're not going to cause problems with this. The worst thing that can happen is it breaks or they don't like it. And I'm okay with that. Like I'll refund someone's money if that's the case. But, the 1 minute balancing appointment was unheard of if you're talking about centric relation splints. Not night guards. Again, night guards, people say, yeah, I balance it in a minute all the time. Yeah, but you only probably have 5 teeth touching. You don't care about guidance if that's what your insertion is looking like. So that kind of wraps up the presentation for the night.
Well, thank you so much, Dr. Owen. I appreciate it. This, I have to be honest, I learned so much in this last 40 minutes or so. I got to be honest, I'm going to rewind the presentation. I'm going to check myself for TMD using your technique. I almost started doing it during the presentation to check for the chatter of the teeth and see if I had that front to back movement. I'll be doing that in the mirror tonight, that's for sure. We do have a couple questions that came through. And so one question came through, and it was asking, do you use, for your wires, for your braces, do you use a mechanical CAD bender for your wires, or do you do it in an analog technique?
So the wires that we use, what's important for me is that I prefer that you use our 1925 nickel titanium wire. And we have 4 different arch widths with that wire. So if your goal is to not overexpand the canines, we have a stock arch form, but we have 4 versions of that. So we can actually kind of do custom arch movement within reason. But if you doctors all the time, you can actually go in and grab the wires in the software and you can change the shape of them. Then you can actually print out a 1X printout of that and then form like a TMA wire. So if you want to even get more refined, you can. You can print out a 1X, then you just hold that form over the wire, and then you bend the wire so it fits that shape that you created. So the big thing for me is I want to be able to go custom whenever you need it, but I don't want you to have to pay custom prices if you don't. And, and that's how we keep the price so much lower than any custom solution that we've ever seen, because I think that for this to really work, you have to be able to use it on every patient, which means the price has to be low enough. You can make this an every patient solution, not just a 3 or 4 a month who are willing to pay the extra $400. That's what I was seeing with Insignia. Hey, do you want to pay the extra $500? No, that's okay. And then, so I'm like, okay, I'm only starting 3 digital patients and braces a month, not 30. And so I still was running an analog schedule. So great question though.
We have 2 more questions that came in. How do you repair a loose bracket with your techniques?
So a couple things. I love saving the indirect bonding tray, because then the staff in most places can do it for you. And with most of the new materials, it's just an X-Acto knife or a scalpel, and you just cut out that one tooth individually, and then you load the bracket into that, and then the assistant can kind of just add the adhesive and seat it right back where they want it to go. If you're using like the custom system, and say you've got multiple locations and you don't want to stock those indirect bonding trays at every place, with our the Stride custom system, since we're within 5 degrees max of deviation, even if you need to direct bond that tooth, you're still getting a way better, as long as you grab the right bracket, and there's a patient prescription for every patient that you'll see that you can scan in the chart. As long as you grab the right bracket and direct bond it, you're totally fine with that too. So you don't have to deviate from the plan, and you can fix it that same day, which is what I love too. When I was doing like Incognito or Harmony or Insignia, some of the brackets would break, and then we're like waiting 5 weeks for them to ship the new one back to us because we just didn't have it in hand. But with these, you'll have backup brackets ready to go.
That's really cool. Well, we have one more question actually popped up. How long do you use your alcohol baths for? How long do they last?
We keep the reservoirs pretty small, and it really does depend on the resin that you're using. Some of these lower viscosity resins, you don't go through the alcohol nearly as quickly, but, just guessing, I would say probably if you're printing quite a few pieces going through it, every 3 to 5 days is probably typical. And we're not changing out all of them. What we do is we have our clean, our medium, and our dirty, and we basically just go and do the distilling on the dirty. The medium shifts to become the dirty, the clean shifts to medium, and then we just put in one new vial of the clean. So just kind of everything, it's like a conveyor belt going down the line. Once we get enough of the dirty collected, then we distill our 99% IPA.
Okay. Thank you for the answer. That was great. The next question is how easy is it to switch materials on the printer?
So we do it where we have just a separate tank, a separate basement, and it's super quick and easy. You just there's these little spring-loaded things, you unattach it. So if you're printing models or if you're printing IDB tray, now what I will tell you is make sure if you're printing models and you're printing in IDB trays or splints, you don't want to use the same wash system, because those washes are with a non-FDA cleared. You don't want to have the model resin being cleaned in a piece that's going to go in the patient's mouth, because there's some of them that are really caustic. So if you are going to be printing things that are biocompatible and things that aren't, you just want to make sure you have a separate track for each one of those. Yeah.
We had one more. The questions are just flowing in, so this is really good. The next question we had is, do you have to calibrate when you're changing between materials?
We don't.
Yeah.
Yeah, we don't. Yeah, it's just a quick swap out. The smart positioning in the Asiga printers, I mean, I love they have a sensor in it that knows exactly when the build plate's going to separate it, so it starts the next print layer right away. But even more than that, they have these little triangulating points where as the printer is going up and down, the Asiga printer will actually recalibrate to the last layer and kind of set it in again. So calibration has not been an issue for us. I don't know what you guys are seeing.
Oh no, it's been great. It's you know, that a lot of, there's some other there may be other printers out there in the industry that you may have to calibrate between, and with the Asiga you don't. There's no calibration between materials. And to feed to the question about changing materials between on the printer itself, it probably takes, I say less than 30 seconds, but I think less than 10 seconds. Yeah, at 30 seconds is if you're taking your time.
But you know, get a second basement. You know,
yeah.
Definitely you don't want to be pouring stuff back and forth and back and forth.
Yeah, definitely recommended to have a material or a resin vat per material type to keep them separated. On the design of your IBTs or indirect bonding trays, do you prefer to go full arch with your trays, or do you prefer to go quadrant, or do you base it off of a patient basis on what you feel is best for them?
You know, so what I can tell you is I'm doing quadrant right now. We have doctors that choose to go sextant. I'm really intrigued about going back to full arch. I think that's going to be with the newer material. With our last 3 generations, I would never have attempted full arch, but now these newer materials, it's getting to the point where I think we can get back to that. Yeah. The issue really is with full arch, how many trays can you fit on the build plate? And so you can usually fit 4 arches, 2 full cases on the build plate if you are doing sextant or quadrant. If you're doing full arch, you're probably only going to fit 1 case on it. Yeah. And so it just depends on what do you need for throughput. If you're okay saying, hey, I'm just going to print 2 separate prints because I want to use full arch, great. Otherwise, quadrant or sextant, you're going to probably be able to double the throughput of the printer.
Yeah. No, that's a good tip. Real good tip. And the final question is, how long does it take for you to normally print your indirect bonding trays on an Asiga Max? So
30 minutes, 25 to 35 is probably the range, just depending on the height, but it's quick.
That's really quick.
You know, the curing time is one of the bigger limitations, and some of the new curing units are getting fast as can be with that as well. So yeah, it's pretty fast.
Great. Well, these are all great questions, and I'd like to thank everybody for joining in on the webinar, and also thank you so much, Dr. Brandon Owen, for sacrificing some of your time for us and educating us. And I am pretty stoked to hop in front of the mirror and check if I have TMD, or at least try to self-diagnose it. I'm not going to get on WebMD afterwards and see if I have it, because it'll say for sure I have it. But thank you so much, Doctor. We really appreciate it.
Thank you guys so much. Thanks for the invitation.
Absolutely. Take care. And once again, everybody, this is recorded. You will see it on YouTube.